Teleportation is a prevalent locomotion technique used for virtual reality applications. Teleportation is commonly performed using controllers, which can negatively impact immersion and limit natural interactions. Hand tracking capabilities on VR devices offer controller-free hand-based interactions for more intuitive and immersive experiences. However, hand-based teleportation techniques commonly rely on arm movement, which limits teleportation activities. In this paper, we present WriArm, a novel teleportation technique that leverages wrist angle in combination with arm movement to provide users with improved control over the movement of the parabolic pointer. Through a set of user studies, we designed and evaluated the performance of WriArm for teleportation tasks. First, we conducted a design study to find a set of hand gestures that can be suitable for teleportation sub-activities, such as activation, which activates the teleportation arc, pointing, which is used to direct the arc, confirmation, which confirms the direction of the teleportation and teleports the user, and cancellation, which deactivates the teleportation arc. From the design study, we selected 3 gesture sets, consisting of 1 gesture for each of the 4 activities. Next, we implemented the gesture sets for arm and WriArm techniques. We then conducted a user study to compare the performance of the techniques and the gesture sets. Each participant performed a series of teleportations at varying distances and heights for the gesture sets and techniques. Here we demonstrate the 2 techniques we evaluated: arm-based pointing, which uses the height and movement of the arm to direct the teleportation arc, and WriArm, which uses the movement of the arm in combination with the angle of the wrist to direct the arc. We now demonstrate the gesture sets with our WriArm technique. When teleporting, users first perform the activation gesture to activate the teleportation parabola. They then use the pointing gesture while moving their arm and angling their wrist to direct the arc towards the platform. Once the user is aiming at the platform, they perform the confirmation gesture to teleport. If the user activates the teleportation arc, points to the platform, but decides not to teleport, we see that they can instead perform the cancellation gesture to deactivate the arc and perform other interactions if they desire. Results showed that users were faster with WriArm than with the arm-based teleportation technique. Users also reported WriArm to be more accurate, cause less fatigue, and feel more natural and intuitive. In addition, results showed that gesture set 4 performed better than other gesture sets due to its simplicity and ease of use. Overall, we demonstrated that WriArm results in faster, easier, and more preferred teleporting performance. We also demonstrated that gesture sets with natural poses and smaller movements perform faster and are preferred for frequent actions.